Good day, everyone. Today, we will be teaching you how to show that a point is on the unit circle. We have 3 different objectives to achieve at the end of our lesson. First is to be able to define a unit circle. Second, to find the equation for unit circles. And lastly, our main objective is to be able to show that a point is on the unit circle. Let us start with this question. What is a unit circle? So, a unit circle is a circle with its center at the origin of the coordinate plane and with a radius of 1 unit. To elaborate, the graph that you are seeing right now is the graph of a unit circle. As you can see, its center is at the origin, which is 0, 0, and it also contains a radius of 1 unit only. Since we now know that a unit circle has a radius of 1 unit only, this means that its x-intercepts are constant, which is positive 1, 0 and negative 1, 0. Same goes for its y-intercepts, which is 0, positive 1 and 0, negative 1. Reviewing our lessons before, we know that any circle with its center at the origin has the equation of x squared plus y squared is equals to r squared, where r is the radius of the circle. In the case of a unit circle, the equation is x squared plus y squared is equals to 1 because the radius of a unit circle is 1. This equation shows that the points lying on the unit circle have to have coordinates that, when you square each of them and then add those values together, they must equal to 1.
Let's start with a simple example, shall we? Determine whether point P with the coordinates square root of 2 over 2 and square root of 2 over 2 is on the unit circle. To start, let's substitute the given coordinates with the general formula. As Grace said earlier, this is the general formula. X squared plus y squared is equal to 1. Let's start solving, shall we? So we have square root of 2 over 2, then square the whole term, plus square root of 2 over 2, then square the whole term again, is equal to 1. Then the next step is to distribute the exponents of the individual terms to both the numerator and the denominator. So with this, we will have 2 over 4 plus 2 over 4. Since when you square root of 2, it cancels out the square root, leaving us with 2. And 2 squared is equal to 4. The same thing with the other term. And then we evaluate. So since the two terms are similar fractions, we will just need to add their numerators, giving us 4 over 4. Simplifying 4 over 4 would give us 1. So 1 is equal to 1. With this, we can now say that point P, which is square root of 2 over 2 and square root of 2 over 2 is on the unit circle. To check, we can use the scientific calculator. Input all of the values. Pressing the equal sign, we can now see that it is indeed equal to 1. And here I have a unit circle which shows some points that are on the unit circle. So here it is indeed shown that square root of 2 over 2 and square root of 2 over 2 coordinates are on the unit circle. But please keep in mind the points on the unit circle shown are points that are frequently used in trigonometry and other math applications, but they aren't the only points on that circle. Every circle has an infinite number of points with all sorts of interesting coordinates, even more interesting than the ones already shown.
Hi everyone, I am Juleah Marie A, Mahusay, and I'm discussing to you the second problem. So determine if these points are on the unit circle or not. So we only need 3 steps. First, unit circle is x squared plus y squared equals to 1. So we need to substitute using these coordinates. So it will become square root of 10 over 5 squared plus square root of 15 over 5 squared equals to 1. Then next we'll proceed to the second step, which is to square these coordinates. So the square root of 10 squared is equals to 10. And 5 squared is equals to 25. Plus the square root of 15 squared, which is 15 over 5 squared, which is 25, equals to 1. The third step is to add these values, and since we have the same denominator, we can add the numerators immediately. So 10 plus 15 is 25, and copy the denominator 25. And this value 25 over 25 is equals to 1. And since it is equals to 1, it equates to number 1. And since it equates to number 1, then the point is on the unit circle. Thank you.
Hi everyone, I am here to discuss the third problem, which is to determine if these points are on the unit circle or not. So let's start. In the unit circle, this is x and this is y, and r is 1. So the standard equation of a unit circle is x squared plus y squared equals 1. We need to substitute the values of x and y. 4 over 5 squared plus negative 3 over 5 squared equals 1 squared. 4 squared is equals to 16 over 5 squared is equals to 25 plus negative 3 squared is equals to 9 and 5 squared is equals to 25 equals 1 squared is equals to 1. So we need to add these values, and since we have the same denominators, we can add the numerators. So 16 plus 9 equals 25. The value 25 over 25 is equal to 1, which means the point is on the unit circle.
So for our last example, we have to determine whether point M having coordinates 1 over 4, 3 over 4 is on the unit circle. To solve, we must remember the standard equation, which is x squared plus y squared is equals to 1. First, we must substitute the x and y coordinates in the equation. 1 over 4 square the whole term plus 3 over 4 square the whole term is equals to 1. Second, we now distribute the square to the numerator and denominator of the x and y coordinates. So that would give us 1 squared over 4 squared plus 3 squared over 4 squared is equals to 1. And that would give us the result of 1 over 16 plus 9 over 16 is equals to 1. Since this is an example of a like fraction, we can just simply copy the denominator and add the numerators. So 1 plus 9 is equals to 10, and just copy the denominator, which is 16. So 10 over 16 is equals to 1. In simplified form is 5 over 8, or in decimal form is 0.625, which is not equal to 1. Therefore, we can conclude that point M having coordinates 1 over 4, 3 over 4 is not on the unit circle.
Here's an example that I wanted to try. Determine whether the point negative square root of 3 over 2 and negative 1/2 is on the unit circle.
So, let's have a review. What again is a unit circle? A unit circle is a circle whose center is at the origin of the coordinate plane, meaning its origin is at 0, 0, and its radius is equal to 1. To determine if a given point is on the unit circle, we use the equation x squared plus y squared is equals to 1. We substitute the given values of x and y and we solve it. If the answer is equal to 1, then that point is on the unit circle. If not,